Hi, it's Mr. Anderson. In this podcast, I'm going to talk about R and K selection, or R-selected and K-selected species. Right here, we've got a chameleon female that's just laid 2 eggs. Right here, we have a frog that's just laid thousands of eggs. One of these is an R-selected, one is a K-selected. If you know exactly which is which right now, then you probably don't need to watch the rest of the video. But for those of you that are now left, let me talk about R and K selection. Basically, we have to talk about population growth. And so any population where you have a positive R, and R stands for growth rate. If you ever have it a positive R, you're going to follow a curve that looks kind of like this. You'll first of all have exponential growth, and then eventually you'll run out of space or food. There's going to be competition, and eventually you're going to hit what's called logistic growth. And so we call this the J-shaped curve, the exponential, or the sigmoidal or the S-shaped curve, which is logarithmic. And so what is N? N is going to be the number of individuals in the population. And so right here, if we put N on this side and we put time on the x-axis, as time goes on, the numbers are going to increase. So this would be a low N value right here, and this would be a higher N value, and this would be a really high N value. And so it's important that you know what N is. That's the number in the population. R is the growth rate. Remember, if it's ever positive, and how do we calculate growth rate? It's basically the number of people being born minus the number of people who die. If we ever have a positive one, then we're going to get this curve. Now, it's not always radical like this. Sometimes it's going to be really gradual like this. Sometimes it's going to be incredibly quick, depending on what the R value is. And then the last thing is K. K stands for carrying. Let's try to spell that right. Capacity. And so basically that means in an area for a certain group of or a certain population, there's like a maximum amount that they can support. And so we call that the carrying capacity. And that's where the limit is. It's eventually going to level out on that. And so if I were to talk about in the real world, because this is just a math formula, basically in the real world, we put wolves back in Yellowstone Park. And so there was tons of food there, not a lot of competition. And so basically their growth rate went up. And then it's dropped, and it's gone up, and it's dropped, and it's kind of reached this carrying capacity, a maximum number of wolves that you're going to have in Yellowstone Park. And so it's not as smooth as that, but it certainly has an R value, the N value has increased, and then it's reached kind of a K. So it's important that you know what N, R, and K are. Another thing that's important is that you understand the way life exists. This is the story of life and death is going to vary, and we really have 3 different types. So you happen to be a type 1 survivorship curve. And what that means is think about all the kids in your class or all the kids who were born on the same day that you were. Basically, most of you are going to survive that first day. And most of you are going to survive. Now, a few people will die right away, but most of you are going to survive. You're going to make it through your teenage years and your middle ages, and eventually you're going to drop off. And all of you are going to die in these last 10, 15, 20 years. That's because we're type 1. We're humans, and we give a lot of, you could see this right here, parental care to our offspring. Now, if we look at a frog, here's some frog eggs down here. They show what's called a type 3 survivorship curve. On day 1, thousands of little frogs, almost all of them die. But a few of them survive, and then they're going to level off, and then they're eventually all going to die. Now, we also have something in the middle, type 2 we call that. Songbirds are an example of that. And so they're going to die off at a linear rate throughout their whole life cycle. And so robins are an example of that. Robins on average live about a year, but some live a few months and some live 3 years. But on average, they're just going to drop off until they're all dead. The cohort, the ones that are born on that one specific day. Remember, our environments are going to differ. Sometimes we're going to live in environments that are relatively stable, like a desert, and sometimes not so much, like a rainforest or even a coral reef, especially right now. They're changing radically almost every day. And so basically, let's get to what an R-selected species is. R-selected are going to be those that base their life on R. And remember, R is growth rate. And so these are species that want to quickly grow and exploit a niche as fast as they can. And so these are things that normally live in an unstable environment. They have high fecundity. What does that mean? Fecundity basically means is that they can make a lot of babies really, really quickly. In general, these things are small. They don't live that long, and their offspring just kind of spread to the ends of the earth. And so an example of this would be a dandelion. They show up really early in the spring. They reproduce quickly. If you've ever seen a dandelion when it goes to seeds, the seeds are just spread out, given very little parental care. Bacteria, insects, diatoms, which are algae, are a type of this, or squid babies are essentially laid by the females Males put sperm all over that. You have these packets, and then the parents just head away. They just leave, and then eventually all the squid are born. Most of them are food for fish, but some of them are able to survive. And so that's the R-selected species. You're putting your life in growth rate. So what's K-selected species? Well, these things are going to put their lives basically around carrying capacity. They're in it for the long haul. Then they're in it for exponential and then that logistic growth. They want to live a long time. Generally, they live in a more stable environment. They're larger as far as body size. They're going to live a lot longer. There's a lot of parental care. So you as a human are going to be a K-selected species. If we look at plants, compare this to the dandelion, a tree like this, some trees will live hundreds, if not thousands of years. Or whales are an example of K-selected species. But you don't necessarily have to be big. This is an Arctic tern that lives decades, and they have a lot of parental care. And so they're K-selected species. Know this, that in life, it's not always one or the other. There are some species that actually show a continuum. And so a sea turtle, you might look at a sea turtle, it's big, lives a really long time. You might say, well, that's maybe a K-selected species. But then if you remember of how they're born, they're just going to lay a bunch of eggs, cover them up in a hole, and then just kind of swim away. And all of these eggs are going to hatch. These little baby sea turtles are kind of on their own. And so that would be more of an R-selected. And so even within a lifetime, you can be R and K-selected. And even by gender. So if you think about it, not humans per se, but in animals, males tend to live more of an R-selected species, produce as many as they can, spread as much of their sperm as far as they can, whereas females are more K-selected, investing a lot in those offspring in that long haul. So let's go back and look at that first slide. The chameleon, is it R or K-selected? Well, it's investing in just these two eggs, and so it's in it for the long haul, where this would be an R-selected species. And I hope that's helpful.